May 1945, Okinawa. Japanese defenders deep within limestone caves watched American soldiers approach their tunnel entrances with growing confidence. They had spent months preparing for this moment, carving elaborate underground networks that turned every hill into a fortress. Their tactics had proven devastatingly effective against conventional assault troops across the Pacific. Machine gun nests positioned at tunnel mouths, interconnected chambers allowing rapid repositioning, and carefully placed explosive charges that could collapse entire sections when needed. The Americans would charge forward with rifles and grenades, only to be cut down by crossfire from positions they couldn't see or reach. It was a proven formula for victory. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. But then something happened that shattered every assumption about underground warfare. Instead of the expected infantry charges, American engineers appeared at tunnel mouths carrying strange cylindrical tanks strapped to their backs. No rifle fire preceded them, no explosive charges were thrown ahead. Instead, they aimed metal nozzles into the darkness and released something that defied every defensive calculation the Japanese had made. Liquid fire poured into their carefully constructed positions like a molten river, flowing around corners, seeping through cracks, and filling every space where air had once been breathable. Within seconds, positions that had taken months to fortify became uninhabitable death traps. The Japanese garrison commanders radioed desperate reports to headquarters describing an enemy weapon that seemed to bend the very laws of physics. Fire that moved like water, flames that traveled upward through vertical shafts, heat that penetrated rock walls and made entire tunnel systems unbearable even when the fire itself hadn't reached them. Traditional defensive tactics crumbled in minutes. Soldiers who had prepared to fight to the death found themselves fleeing positions they had sworn to defend, driven out not by bullets or explosives, but by an element they had never trained to counter. What the Imperial Japanese Army had encountered was not just a new weapon, but a complete revolution in assault tactics. The M2 flamethrower system represented a technological breakthrough that transformed underground warfare from a defender's advantage into an attacker's opportunity. Yet the true genius of this weapon lay not merely in its ability to project fire, but in how American engineers had solved problems that conventional weapons couldn't touch, creating a tool specifically designed to neutralize the one tactical advantage that had consistently frustrated Allied advances across the Pacific theater. The story begins not with American innovation, but with Japanese tactical brilliance that had stymied Allied forces for years. Throughout 1943 and 1944, Imperial Army engineers had perfected what they called cave warfare, transforming natural limestone formations and volcanic rock into impregnable defensive positions. On islands like Peleliu, Iwo Jima, and Saipan, these underground fortresses had turned what should have been swift victories into prolonged bloodbaths. American planners studied after-action reports with growing frustration, watching casualty rates climb as traditional assault methods proved inadequate against enemies who literally vanished underground. The Japanese system was devastatingly effective in its simplicity. Primary tunnels connected multiple firing positions, allowing defenders to appear, fire, and disappear before counterfire could reach them. Secondary passages provided escape routes when positions became untenable. Ammunition storage chambers, command posts, and even medical stations were carved deep enough to survive direct hits from battleship guns. Most critically, the tunnel mouths were positioned to create interlocking fields of fire that turned any approach into a killing zone.
Defensive networks, had studied American assault tactics extensively. He understood that Marines relied on overwhelming firepower, followed by rapid advances. His tunnels were designed to absorb that firepower harmlessly while channeling American troops into predetermined kill zones. Machine gun positions were recessed deep enough that grenades couldn't reach them. Connecting passages were too narrow for effective use of demolition charges. Even when Americans managed to suppress one firing position, defenders could retreat through tunnels and emerge from entirely different locations. The effectiveness of this system was proven repeatedly in blood. At Peleliu in September 1944, what was supposed to be a 3-day operation stretched into more than 2 months. American casualties mounted as Marines found themselves attacking positions they couldn't see, couldn't reach, and couldn't destroy with conventional weapons. Every cave entrance became a separate siege, with defenders able to hold out for days or even weeks while inflicting casualties far out of proportion to their numbers. Intelligence reports from captured Japanese documents revealed the scope of their underground preparations. On Okinawa alone, military engineers estimated that defending forces had carved more than 60 miles of tunnels through the limestone bedrock. Some chambers were large enough to house entire companies, complete with ventilation systems, drainage channels, and reinforced ceilings capable of withstanding repeated artillery bombardments. The Japanese had effectively created a second battlefield beneath the surface, where all the advantages traditionally held by attacking forces disappeared. American weapons development teams studied these reports with growing urgency. Standard infantry equipment proved useless against tunnel positions. Rifles couldn't engage targets they couldn't see. Machine guns were ineffective against recessed positions. Hand grenades lacked the range to reach deep emplacements. Even bazookas and recoilless rifles, effective against surface bunkers, struggled with the angular geometry of tunnel warfare where direct lines of sight rarely existed. Flamethrower technology had existed since World War I, but early models were primitive, dangerous, and limited in application. The original systems used a mixture of gasoline and oil that created spectacular but short-lived flames. Range was minimal, reliability poor, and the operators themselves faced constant risk from their own equipment. Most critically for Pacific warfare, these early flamethrowers were designed for surface combat against trenches and bunkers, not for the unique challenges of underground fighting. The breakthrough came in late 1943 when the U.S. Army Chemical Warfare Service began developing what would become the M2 flamethrower system. Unlike its predecessors, the M2 was engineered specifically with tunnel warfare in mind. The fuel mixture was reformulated to create flames that not only burned hotter, but also flowed more effectively around obstacles. The ignition system was redesigned for reliability in humid Pacific conditions. Most importantly, the pressure system was optimized to project streams of burning fuel over greater distances and through more complex geometries. Dr. Maurice Bensinger, the chief engineer behind the M2 development, understood that the weapon needed to do more than just create fire. It needed to create fire that could travel through tunnels, around corners, and into spaces where conventional weapons couldn't reach.
Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story.
Thickened gasoline or napalm had a consistency that allowed it to stick to surfaces and continue burning for extended periods. Unlike earlier flamethrowers that produced spectacular but brief fireballs, the M2 created sustained flames that could completely alter the environment inside enclosed spaces. Testing began in early 1944 at proving grounds designed to replicate Pacific tunnel conditions. Engineers constructed mock cave systems using the same limestone and volcanic rock found on Japanese-held islands. Initial trials revealed capabilities that surprised even the weapons designers. The M2 could project burning fuel around corners through ricochet techniques. Flames traveling through tunnel systems created convection currents that drew oxygen from connected chambers, making the entire network uninhabitable. Most remarkably, the heat generated by burning napalm could raise temperatures in adjacent passages to levels that forced evacuation, even when flames never directly reached those areas. Production began in earnest by late 1944. The Crosby Manufacturing Company in Massachusetts converted automotive assembly lines to produce the specialized tanks and nozzle systems. DuPont Chemical supplied the napalm formulation from newly constructed facilities in Delaware. Training centers in California and Hawaii began teaching American troops not just how to operate the weapons, but how to employ them tactically in underground combat situations. The men selected to carry M2 flamethrowers represented a unique breed of specialist. Unlike conventional infantrymen who could rely on cover and concealment, flamethrower operators had to advance directly toward enemy positions, carrying highly visible and valuable targets on their backs. The psychological profile required was specific.
men who could function effectively under extreme stress while bearing equipment that made them priority targets for every enemy gunner. Staff Sergeant Robert Chen of the 96th Infantry Division was among the first operators trained on the new system. His unit spent weeks practicing tunnel assault techniques at the Schofield Barracks training facility in Hawaii. The training was as psychological as it was technical. Operators had to learn to move confidently toward tunnel mouths, knowing that machine guns were certainly trained on them. They practiced coordinating with rifle squads who would provide covering fire during the critical moments when flamethrower teams approached their targets. The tactical doctrine that emerged was revolutionary. Instead of trying to suppress tunnel positions with rifle fire or explosives, assault teams would use the M2 to deny the tunnels entirely to their defenders. A single flamethrower operator could neutralize positions that had previously required entire platoons to reduce. The technique was as much about area denial as direct destruction. Even after flames died down, tunnel systems remained unusable for hours due to residual heat, toxic gases, and oxygen depletion. Training scenarios revealed the true versatility of the weapon system. Operators learned to use walls and ceilings as deflection surfaces, bouncing streams of burning fuel around obstacles to reach positions that seemed impossible to target directly. They practiced techniques for attacking vertical tunnel systems, using the natural tendency of flames to rise as a tactical advantage. Most importantly, they learned to work in coordination with conventional infantry, timing their attacks to maximize the psychological impact on enemy defenders. The first combat deployment of the M2 system came during the Luzon campaign in the Philippines in early 1945. Japanese forces had prepared extensive tunnel networks in the mountains north of Manila, confident that their underground positions would repeat the success of earlier defensive battles. American planners decided to test the new flamethrower tactics against these positions before the anticipated invasion of Japan itself.
Near Baguio in March 1945. Intelligence estimated that approximately 200 defenders occupied a network of caves and passages carved into volcanic rock. Previous attacks using conventional methods had failed to dislodge them, despite weeks of artillery bombardment and infantry assaults. The Japanese position commanded a critical mountain pass, and reducing it was essential for the continued advance toward Manila. The attack began at dawn with a brief artillery barrage designed more to fix enemy attention than to cause damage. As the shells fell, Torres and his three-man flamethrower team advanced up the slope toward the primary tunnel entrance. Japanese machine gunners opened fire as expected, but supporting American riflemen kept them suppressed just long enough for Torres to reach effective range. When he triggered the M2 system, the results exceeded every prediction from training exercises. The stream of burning napalm struck the tunnel mouth and immediately began flowing inward like liquid lightning. Japanese defenders who had weathered months of conventional bombardment found themselves facing a weapon that turned their defensive advantage into a death trap. The fuel mixture flowed around the corners and obstacles they had carefully positioned to block rifle fire and grenades. Within minutes, positions that had held against regiment-sized attacks were abandoned as defenders fled through emergency exits, many of them suffering from severe burns and smoke inhalation. What surprised American observers most was not just the immediate tactical success, but the psychological impact on defenders throughout the tunnel network. Even positions that flames never reached directly were evacuated, as word spread through the underground complex about the new American weapon. Japanese soldiers who had prepared to fight to the death found themselves confronting an attack method they had no training or equipment to counter. The success at Baguio led to rapid deployment of M2 systems throughout American forces preparing for the Okinawa invasion. By April 1945, every assault regiment had trained flamethrower teams equipped with the new weapons. Tactical manuals were hastily rewritten to incorporate underground warfare techniques that had been proven effective in the Philippines. Most importantly, American planners began to understand that they possessed a weapon capable of neutralizing the defensive advantages that had made previous Pacific campaigns so costly. The Japanese, meanwhile, remained largely unaware of the technological breakthrough that was about to render their most effective defensive tactics obsolete. Intelligence reports from Luzon mentioned new American weapons, but failed to convey the revolutionary nature of the M2 system. Japanese commanders continued to believe that their tunnel networks would provide the same defensive advantages that had worked so successfully on earlier battlefields. They prepared for the defense of Okinawa, confident that American troops would once again be forced to assault fortified positions with the same conventional methods that had proven so costly in the past. General Mitsuru Ushijima, commanding the 32nd Army on Okinawa, had spent months perfecting what he considered the ultimate evolution of tunnel warfare. His defensive network incorporated lessons learned from every previous battle, with improvements designed to counter every American tactic that had shown effectiveness against underground positions. Tunnels were deeper, more complex, and better ventilated than any previous system. Command and control networks allowed coordination between widely separated positions. Supply caches were distributed throughout the network to allow prolonged resistance even if surface communications were cut. What General Ushijima and his staff could not have anticipated was that American forces were no longer limited to the conventional weapons that had made tunnel warfare so effective for defenders. The M2 flamethrower represented a technological leap
that transformed the fundamental equations of underground combat. For the first time in the Pacific War, American assault troops possessed a weapon specifically designed to exploit the vulnerabilities of tunnel systems, rather than being stymied by their strengths. The stage was set for a confrontation that would prove whether Japanese tunnel tactics could adapt to counter American technological innovation, or whether the M2 flamethrower would render months of defensive preparation useless. The limestone caves of Okinawa would become a testing ground, not just for military tactics, but for the collision between traditional defensive thinking and revolutionary assault technology. As American invasion fleets approached Okinawa in March 1945, Japanese defenders settling into their carefully prepared tunnel positions had no way of knowing that the nature of underground warfare was about to change forever. They prepared for battle confident in tactics that had worked successfully for more than a year across the Pacific. They would soon discover that confidence built on past success could become a fatal weakness when confronted with weapons designed specifically to exploit the vulnerabilities they had never been forced to consider. The invisible revolution in flamethrower technology was about to become devastatingly visible in the tunnels beneath Okinawa's hills, where liquid fire would prove more decisive than any conventional explosive, and where the advantage would shift permanently from defenders who hid underground to attackers who could deny them any place to hide. April 1st, 1945. Operation Iceberg began with the largest Pacific amphibious assault of the war. 180,000 American troops prepared to storm the beaches of Okinawa, facing a Japanese garrison that had transformed the island into what they believed was an impregnable fortress. General Simon Bolivar Buckner's 10th Army carried with it the most advanced collection of flamethrower equipment ever assembled for combat, though few understood just how decisively these weapons would reshape the coming battle. The initial landings proceeded with surprising ease. American forces encountered minimal resistance as they established beachheads and began advancing inland. Japanese commanders had learned from previous defeats, abandoning the futile tactic of defending beaches in favor of drawing invaders into carefully prepared killing zones centered around their tunnel networks. General Ushijima's strategy was simple: allow the Americans to advance until they encountered the Shuri Line, a defensive complex that represented the ultimate evolution of tunnel warfare. For 2 weeks, American forces pushed steadily southward, meeting only scattered resistance. Optimistic reports flowed back to commanders who began to hope that Okinawa might prove less costly than feared. That optimism died abruptly on April 19th, when the 96th Infantry Division encountered the first major tunnel complex near Kakazu Ridge. Traditional assault methods immediately bogged down against positions that seemed impossible to locate, much less destroy. Artillery bombardments that should have pulverized defensive positions had no visible effect.
Infantry advances were met with devastating fire from guns that appeared and disappeared like ghosts. Staff Sergeant Chen's flamethrower team received orders to assault a tunnel entrance that had already repelled 3 separate attacks. The position was carved into limestone bedrock 30 feet below the ridge crest, with a narrow opening barely visible among the rocks. Intelligence estimated that at least a platoon of Japanese defenders occupied interconnected chambers behind that entrance, armed with machine guns, mortars, and enough supplies to hold out indefinitely. Chen approached the target with a confidence born from successful training exercises, but nothing had prepared him for the reality of combat conditions on Okinawa. The tunnel mouth was positioned to provide interlocking fire with 2 other positions, meaning that advancing toward any single entrance
exposed assault teams to fire from multiple directions. Smoke and dust from continuous bombardment limited visibility to a few yards. The limestone terrain created unpredictable ricochet patterns that made every footstep potentially fatal. When Chen finally reached effective range and triggered his M2 system, the results exceeded every expectation from training. The pressurized stream of napalm struck the tunnel entrance and immediately began flowing inward with the consistency of burning syrup. Japanese machine gunners, who had been firing from deep within the protected passage, suddenly found themselves facing a river of fire that followed every twist and turn of their carefully engineered defensive position. The flames reached chambers 20 yards from the entrance, driven by the same air circulation systems that Japanese engineers had installed to make prolonged occupation possible. Within 5 minutes, defenders began emerging from secondary exits scattered across the ridgeline, many suffering from severe burns and smoke inhalation. Others remained trapped in the deeper chambers as the fire consumed all available oxygen. The position that had held against conventional attacks for days was completely neutralized by a single flamethrower operator in less than 10 minutes. Word of the success spread rapidly through American units. Battalion commanders who had been preparing for weeks of costly siege warfare suddenly found themselves possessing a weapon that could reduce the most formidable positions in minutes. More M2 systems were rushed forward from supply depots. Tactical doctrine was hastily revised to incorporate flamethrower teams into every major assault. The Japanese response was swift but inadequate. Colonel Yahara Hiromichi, General Ushijima's chief of staff, issued emergency orders for modifications to tunnel defensive systems. Engineers began installing blast doors designed to seal passages when flamethrower attacks began. Ventilation systems were redesigned to prevent fire from spreading through the networks. Some positions were equipped with water pumps intended to flood passages and extinguish attacking flames. These countermeasures proved largely ineffective against the M2's capabilities. Blast doors that could stop rifle fire and grenade fragments could not prevent burning napalm from seeping through gaps and cracks. Water systems designed to extinguish conventional fires were overwhelmed by flames that burned at temperatures exceeding 1,500 degrees Fahrenheit. Most critically, the modifications required time and resources that Japanese defenders simply did not possess as American attacks intensified. Lieutenant Commander Yoshida Mitsuo experienced the futility of these defensive improvements firsthand during the battle for Sugarloaf Hill in May 1945. His company had spent weeks reinforcing a tunnel complex that incorporated every available countermeasure against flamethrower attacks. Steel doors sealed the main passages. Water lines were installed throughout the network. Emergency ventilation systems were designed to evacuate toxic gases. The position seemed invulnerable to any weapon the Americans could deploy. When Sergeant Michael Kowalski's flamethrower team approached the primary tunnel entrance on May 14th, Yoshida's men were confident in their preparations. The blast doors were sealed, water pumps were ready, and alternate firing positions were prepared in case the main network became untenable. That confidence lasted exactly 18 seconds after Kowalski triggered his M2 system. The stream of burning napalm struck the tunnel mouth with devastating force, but instead of being stopped by the sealed blast doors, it began pooling in the entrance chamber. The steel doors that were supposed to provide protection instead trapped the fire in the confined space, creating temperatures that exceeded the melting point of the door mechanisms themselves. Burning fuel seeped through gaps around the door frames, following ventilation ducts and drainage channels that connected to the main network.
Tunnel network. Within minutes, the carefully engineered defensive system became a death trap. Water pumps that were meant to extinguish flames instead created superheated steam that made the tunnels uninhabitable. Emergency ventilation systems designed to remove toxic gases instead drew the fire deeper into the network, spreading flames to chambers that should have been completely protected. The modifications intended to counter flamethrower attacks had actually made the position more vulnerable to them. Yoshida ordered evacuation through emergency exits, but many of his men were already trapped by fires that had spread through passages they had considered completely secure. The position that had taken months to fortify and reinforce was completely destroyed in less than 20 minutes. More critically for Japanese defensive planning, the attack demonstrated that conventional countermeasures were not just ineffective against M2 flamethrowers, but could actually amplify their destructive capabilities. Similar scenes played out across the Shuri line throughout May 1945. American flamethrower teams developed increasingly sophisticated techniques for attacking tunnel systems. Multiple operators learned to coordinate their attacks, with one team forcing defenders deeper into tunnel networks while another attacked from secondary entrances. Some teams discovered that they could create convection effects by igniting fires at different levels of multi-story tunnel systems, using natural air circulation to spread flames through entire complexes. The psychological impact on Japanese defenders became as significant as the physical destruction. Soldiers who had trained to fight in enclosed spaces found themselves facing an enemy weapon that turned those spaces into furnaces. The traditional Japanese emphasis on fighting to the death became meaningless when positions could be made uninhabitable rather than simply suppressed. Many units began evacuating defensive positions at the first sign of flamethrower attacks, abandoning carefully prepared positions rather than facing incineration. General Ushijima's staff struggled to develop new tactics that could counter the American flamethrower advantage. Intelligence reports from surviving tunnel defenders described weapons that seemed to violate the basic principles of defensive warfare. Fire that could travel around corners, flames that could be projected with rifle-like accuracy, heat that could clear entire tunnel networks without direct flame contact. Some reports were dismissed as combat hysteria until multiple independent sources confirmed the devastating effectiveness of the M2 systems. Desperate measures were attempted. Some tunnel positions were equipped with explosive charges designed to collapse entrances when flamethrower attacks began. Others installed chemical systems intended to create oxygen-depleted atmospheres that would prevent flame propagation. A few positions experimented with foam systems borrowed from naval fire suppression equipment. None of these measures proved effective against weapons specifically engineered to operate in exactly the conditions that Japanese defenders were trying to create. The battle for Shuri Castle in late May 1945 demonstrated the complete transformation of tunnel warfare. The ancient fortress had been converted into what Japanese engineers considered their masterpiece of defensive preparation. Multiple levels of tunnels connected dozens of firing positions. Underground galleries provided protected movement between widely separated strongpoints. Supply chambers and command posts were carved deep enough to survive direct hits from the largest American naval guns. The complex represented the culmination of everything Japanese forces had learned about defensive tunnel construction. Captain Alana Rodriguez of the 1st Marine Division led the assault on the castle's main defensive complex on May 21st. Her battalion had been stalled for 3 days by fire from positions that seemed impossible to locate or suppress. Artillery bombardments reduced the surface structures to rubble, had no effect on defenders who operated from tunnels carved into solid bedrock. Previous infantry assaults had been repelled with heavy casualties by interlocking fire from positions that appeared and disappeared without warning. Rodriguez's attack began with a coordinated flamethrower assault involving 6 M2 teams attacking different tunnel entrances simultaneously.
The technique had been developed through weeks of combat experience, with each team positioned to prevent defenders from escaping through alternate exits. When the attack began, streams of burning napalm penetrated the tunnel network from multiple directions, creating fires that converged in the deeper chambers where Japanese commanders had established their command posts. The result was devastation on a scale that surprised even experienced flamethrower operators. The interconnected tunnel system that had been designed as a defensive advantage became a liability as fire spread through passages that connected every position. Ventilation systems that were meant to allow prolonged occupation instead carried flames and toxic gases throughout the complex. Within an hour, the entire fortress was abandoned by defenders who had no choice but to evacuate or face incineration. Japanese casualties from flamethrower attacks began to mount not just from direct flame contact, but from the secondary effects of fighting in environments where M2 systems had been employed. Smoke inhalation, heat exhaustion, and carbon monoxide poisoning became major causes of combat losses. Medical facilities were overwhelmed with burn victims requiring treatment that exceeded available resources. More significantly, many units began suffering from what would later be recognized as combat stress reactions specifically related to fighting in enclosed spaces. The American advantage extended beyond the immediate tactical effects of the weapons themselves. M2 flamethrower operators developed techniques that maximize the psychological impact of their attacks. Teams learned to time their assaults for maximum visibility, ensuring that defenders throughout tunnel networks could observe the effects of flame attacks on adjacent positions. Some operations deliberately left escape routes open, allowing traumatized survivors to spread accounts of flamethrower effectiveness to other defensive positions. Intelligence gathered from captured Japanese documents revealed the extent to which flamethrower attacks were disrupting enemy morale and tactical planning. Unit commanders reported difficulty maintaining discipline when troops were ordered to occupy positions that had previously been attacked with flame weapons. Engineers complained that defensive construction was being hampered by workers who refused to enter tunnel systems where flamethrower attacks had occurred. Supply operations were disrupted as personnel avoided approaching positions that might be targeted by American flame teams.
Include flame weapons. Some Japanese units began positioning their defenses in areas that they considered less vulnerable to flamethrower attacks, often accepting tactical disadvantages in exchange for reduced vulnerability to flame weapons. General Buckner's staff began incorporating flamethrower capabilities into strategic planning in ways that would have been impossible with conventional weapons. Assault schedules were adjusted to allow flamethrower teams to reduce major defensive positions before follow-on forces advanced. Supply priorities were shifted to ensure adequate napalm stocks for sustained flame operations. Most significantly, casualty projections for future operations were dramatically reduced based on the demonstrated effectiveness of flame weapons against tunnel defenses. The success of flamethrower operations on Okinawa led to accelerated production and deployment throughout the Pacific theater. Manufacturing facilities in the United States were expanded to produce thousands of additional M2 systems. Training programs were established to convert conventional infantry into specialized flame operators. Tactical manuals were completely rewritten to incorporate lessons learned from tunnel warfare operations. By June 1945, American forces possessed the most advanced flamethrower capabilities in military history. The M2 system had evolved through combat experience into a weapon system that could neutralize defensive positions that had previously required weeks of siege warfare to reduce. More importantly, the psychological impact of flame weapons had fundamentally altered the tactical equation of underground combat, transforming tunnel systems from defensive advantages into potential death traps. Japanese commanders attempting to prepare defenses for the anticipated invasion of Japan faced an impossible dilemma. Traditional tunnel warfare tactics had proven ineffective against American flamethrower weapons, but no alternative defensive strategies had shown promise against the overwhelming material superiority of Allied forces. Intelligence estimates suggested that American forces were planning to deploy flamethrower teams on a scale that would make tunnel defenses untenable throughout the Japanese home islands. The final major demonstration of M2 effectiveness came during the reduction of Japanese positions around Naha in late June 1945. The city had been fortified with an extensive network of underground positions that incorporated every lesson learned from previous defensive battles. Command bunkers were positioned at depths that should have made them immune to any American weapon. Supply tunnels were designed with multiple alternate routes that could continue operations even if primary passages were blocked. Fighting positions were engineered to provide maximum protection while maintaining effective fields of fire. Major James Patterson's Flamethrower Company received orders to reduce the Naha defensive complex using tactics that had been developed through months of combat experience. His teams had refined their techniques to the point where tunnel assaults resembled precision operations rather than the desperate charges that had characterized early flamethrower attacks. Operators worked in coordinated pairs, with one team providing covering fire while another advanced to effective range. Target selection was based on detailed intelligence about tunnel layout and ventilation systems. The assault began at dawn on June 18th with simultaneous attacks on 12 separate tunnel entrances. Each flamethrower team was equipped with detailed maps showing the internal layout of their assigned targets, allowing them to position their attacks for maximum effectiveness. Instead of simply projecting flames into tunnel mouths, operators aimed their weapons to exploit specific vulnerabilities in Japanese defensive construction. The results exceeded every previous demonstration of flamethrower effectiveness. Within 2 hours, the entire Naha defensive complex was neutralized, with minimal American casualties.
Japanese defenders who had prepared for weeks of siege warfare found their positions completely untenable within minutes of the first flame attacks. The speed and completeness of the victory demonstrated that American flamethrower capabilities had evolved to the point where traditional defensive tactics were no longer viable against them. Captured documents from the Naha garrison revealed the extent to which Japanese forces had become demoralized by repeated encounters with American flame weapons. Unit reports described soldiers who refused to enter tunnel positions, officers who abandoned defensive plans when informed that flamethrower attacks were likely, and entire companies that evacuated positions at rumors of approaching flame teams. The psychological dominance of M2 flamethrowers had become as significant as their tactical effectiveness. The end of organized resistance on Okinawa in June 1945 marked the complete transformation of tunnel warfare from a Japanese defensive advantage into an American offensive tool. Intelligence estimates suggested that flame weapons had been responsible for neutralizing more than 80% of major Japanese defensive positions, often with minimal supporting fire from conventional weapons. The M2 flamethrower had proven capable of rendering months of defensive preparation useless in a matter of minutes. American planners preparing for Operation Downfall, the projected invasion of Japan, incorporated flamethrower capabilities as a central element of their assault strategy. Intelligence indicated that Japanese home island defenses relied heavily on tunnel systems similar to those encountered on Okinawa. The demonstrated effectiveness of M2 weapons against such positions suggested that many of the defensive advantages that Japanese forces hoped to exploit could be neutralized by flame attacks. The atomic bombing of Hiroshima and Nagasaki in August 1945 ended the war before Operation Downfall could be launched, but post-war analysis confirmed that American flamethrower capabilities would likely have proven decisive against Japanese tunnel defenses. Captured Japanese planning documents revealed defensive strategies that were based on assumptions about American tactical limitations that no longer applied after the development of effective flame weapons. The legacy of M2 flamethrower operations extended far beyond their immediate tactical impact. Military engineers studying post-war combat reports concluded that tunnel warfare as a defensive strategy had become obsolete in the face of weapons specifically designed to exploit the vulnerabilities of underground positions. The psychological dominance of M2 flamethrowers had become as significant as their tactical effectiveness. The end of organized resistance on Okinawa in June 1945 marked the complete transformation of tunnel warfare from a Japanese defensive advantage into an American offensive tool. Intelligence estimates suggested that flame weapons had been responsible for neutralizing more than 80% of major Japanese defensive positions, often with minimal supporting fire from conventional weapons. The M2 flamethrower had proven capable of rendering months of defensive preparation useless in a matter of minutes. American planners preparing for Operation Downfall, the projected invasion of Japan, incorporated flamethrower capabilities as a central element of their assault strategy. Intelligence indicated that Japanese home island defenses relied heavily on tunnel systems similar to those encountered on Okinawa. The demonstrated effectiveness of M2 weapons against such positions suggested that many of the defensive advantages that Japanese forces hoped to exploit could be neutralized by flame attacks. The atomic bombing of Hiroshima and Nagasaki in August 1945 ended the war before Operation Downfall could be launched, but post-war analysis confirmed that American flamethrower capabilities would likely have proven decisive against Japanese tunnel defenses. Captured Japanese planning documents revealed defensive strategies that were based on assumptions about American tactical limitations that no longer applied after the development of effective flame weapons. The legacy of M2 flamethrower operations extended far beyond their immediate tactical impact. Military engineers studying post-war combat reports concluded that tunnel warfare as a defensive strategy had become obsolete in the face of weapons specifically designed to exploit the vulnerabilities of underground positions. The psychological dominance of M2 flamethrowers had become as significant as their tactical effectiveness.
Equipment for operators. The basic principles demonstrated on Okinawa continue to shape military research into area denial weapons and siege warfare techniques. Combat veterans who had operated M2 systems carried their experience into post-war military careers, influencing tactical doctrine and training programs for subsequent generations of soldiers. Their accounts of flamethrower effectiveness against seemingly impregnable positions became foundational elements of military education about the importance of technological advantages in overcoming tactical disadvantages. The transformation of tunnel warfare demonstrated during the Okinawa campaign provided lessons that extended beyond military applications. Engineers studying the physics of flame propagation in confined spaces made discoveries that influenced industrial fire suppression systems and building safety codes. The psychological research conducted on combat stress reactions related to flamethrower attacks contributed to understanding of trauma responses in civilian emergency situations. By war's end, the M2 flamethrower had established itself as one of the most decisive weapons of the Pacific theater, not through overwhelming destructive power, but through its ability to neutralize specific defensive advantages that had proven decisive in earlier battles. The weapon demonstrated that technological innovation targeted at particular tactical problems could prove more effective than general improvements in firepower or protection. The invisible revolution in assault tactics represented by flamethrower development became visible in the abandoned tunnel systems of Okinawa, where liquid fire had proven more decisive than any conventional explosive and where the tactical advantage had shifted permanently from defenders who sought protection underground to attackers who could deny them any sanctuary from the flames that followed them into the deepest recesses of their carefully constructed fortresses.
Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.